Okay, so let's combine all of our transformations. So we studied vertical stretches represented by A. Okay, if A is a negative number, then we have a reflection in the x-axis. And this is a transformation that occurs outside the function, so this only affects the y values. The other transformation that affects the y values, because it's outside the function, is the c value. That's the translation, vertical translation. Positive is going up, negative if it's going down. The transformations that affect the inputs are the k value. This is your horizontal stretch or compression. It's also, if it's negative, it's a reflection in the y-axis. And here your d value, which is a horizontal translation. If this operation is a subtraction, x minus d, inside these brackets, remember k has to be factored out, then your graph is a shift to the right. And if the operation is an addition, x plus d, then it's your graph that shifts to the left. Okay, so again, filling in our notes, just writing that down here. A affects the graph of f of x by stretching vertically by a factor of a, and if a is negative, there is a reflection in the x-axis. The d value affects the graph by translating left or right by d units, and the c affects the graph by translating up or down c units. The k value is your horizontal stretch or compression by a factor of 1 over k, and if k is negative, you have a reflection in the y-axis. Now, it's very important to understand that order in your transformations matters. So yes, you must always do your stretches first. So stretch slash compression, and then you translate. So then you move the graph up or down. So then translate. So multiplication before addition and subtraction. Okay, so how do we graph point by point? You start with your base function always. So all of this that you see here, this entire transformation equation, that equation can work for any of the base functions that we're studying in this course. So start by graphing the base function, use the key points, okay? Then you're going to do those point transformations. You take your key points, multiply your y values by a, so that you get a times y. Look for your k transformations. So then you're going to take your x values and divide by k. So that will take care of your stretches and compressions and reflections. And then your translation. So you look for your d value, then you're going to adjust your x, look for the c value, and you're going to adjust your y. Okay? So let's look at some examples. So here's the first example. G of x is the transformation of f of x, and f of x is the square root function. So what's going on here? Well, let's look at how x and y are being transformed. So there's no k value, k is equal to 1. But I do have a d value, and d is equal to positive 3. Remember, if the operation's a minus, it's a shift to the right. D itself is actually a positive 3. So x, I'm going to adjust my x values from my base graph by adding 3. All right, stretches and compressions for the y values. Here, negative 2. Okay, so negative 2 times y. Then your other transformation is a translation plus 4 units. So 2 negative 2y plus 4. So describing the transformations here, we have a reflection on the x-axis. We have a vertical stretch by a factor of 2. We translate the graph 3 units to the right and 4 units up. Okay, so we can look at the base graph coordinates, x and y. This is the square root function we're dealing with here, as it says up here in the question. So let's start with the key points, 0, 1, 4, 9, and 0, 1, 2, and 3 for the y values. Now when I transform them, we're going to look at x plus 3, and we're going to do negative 2y plus 4. So add 3 to every x value, so that's pretty simple. We're going to have 3, 4, 7, and 12. For every y value, multiply by negative 2 and add 4. So the first one will be 4. Next one will be positive 2, and 2 times negative 2 is negative 4 plus 4 is 0. 3 times negative 2 is negative 6 plus 4, which is negative 2. So there are my transform coordinates. I can now graph my transformed function. And here we go. Okay, so there it is. It's a reflection in x, so it's flipped upside down. It's vertically stretched by 2, and it's shifted up 4 and to the right 3 from the origin there. Okay, so there's our first graph. All right, so what about x squared, this quadratic graph? Given this set of transformations, a equals 2, d equals negative 1, and k equals negative 1. So what am I looking at here for my transformations? Well, my mapping coordinates, so let's talk about the stretches and compressions. So a is 2, so I'm going to multiply my y values by 2, so 2y. There is no horizontal stretch or compression, so x stays as x. Now my translations. Okay, I'm going to translate left 1 unit, so x minus 1, and translate down 1 unit because k is negative 1, so 2y minus 1. So there's my mapping notation. Take the key points on x squared, so x and y equals x squared, negative 2, negative 1, 0, 1, and 2, so 4, 1, 0, 1, and 4, and transform them. So x minus 1, 2y minus 1. So take your x value, subtract 1, so negative 3, negative 2, negative 1, 0, and 1. Take your y values, multiply them by 2, and subtract 1. So 4 times 2 is 8, minus 1 is 7. 1 times 2 is 2, minus 1 is 1. Here I have negative 1, and then repeat 1 and 7. Graph your points. Negative 3 and 7, negative 2 and 1, negative 1 and negative 1, 0 and 0 and 1, and then 1 and 7 again. So there is my parabola, and you're done. Okay, let's look at another one. Square root of 2x plus 4 plus 1. There's something you have to remember here. Remember, you have to rewrite 2x plus 4 in factored form so you can figure out your horizontal translation. So if I do that, I should get the square root of 2 times x plus 2, and then outside your square root is plus 1. Aha! So now we get a true value what the d value is. It's a shift to the left by 2 units. Okay? So x and y, this is the square root function as my base, so 0, 1, 4, 9, and 0, 1, 2, 3. So what's the mapping going to look like? So it's a shift left by 2, so x minus 2. Horizontal, now k is greater than 1, so that's going to be horizontal compression by a factor of 1 over k, so 1 over 2. So multiply your x by 1 over 2 first, then you subtract 2. Okay. What about my y values? The only thing that's going to change is you're going to add 1 to every y value because of the vertical translation up by 1 unit. Okay, so take every x value, divide it by 2, and subtract 2. So here I'm going to have negative 2. 1 divided by 2 minus 2 is, 0.5 minus 2 is negative 2.5. 4 divided by 2 is 2, minus 2 is 0. 9 divided by 2 is 4.5, the minus 2 is 2.5. Y values plus 1 will go 1, 2, 3, and 4. And now I can plot my points, negative 2 and 1, negative 2.5 and 2, 0, and, looks like I made a mistake somewhere. This one here, 0.5 minus 2 is negative 1.5. Yeah, okay. Negative 1.5 is here, and 2, 0, and 3, 2.5, and 4. There we go. And there's my new transformed radical function. Okay, so what if you're given descriptions and asked to write an equation? It's pretty simple. So here, verticals, write the equation. So vertical stretch by a factor of 1 over 2. So A is equal to 1 over 2. Reflection in the x-axis. So A is negative. So let's change this to A equals negative 1 over 2. And we have a translation 3 units to the right. So D is going to be 3. It's going to the right. Okay. So Y equals, A comes first, negative 1 over 2. Just follow this formula here. Your function f, we don't know what the function is. We don't know if it's a square root function or a quadratic function or whatever function. So leave it as f. K, there's no k value. Okay, x plus, so if d is plus 3, if d is positive 3, then your equation is going to be x minus 3. And then we have, well, that's it. Okay. No other translations up or down, up or down. So no c value at the end. Okay, let's look at a vertical stretch. Another one, a vertical stretch by a factor of 3. So A is equal to 3. Horizontal stretch by a factor of 2. So be very careful here. That means K is equal to 1 over 2. Remember, horizontal stretch, when we talk about horizontal stretches, we're always talking about by a factor of 1 over K. So what is the K value for this to be equal, for the factor for 1 over K to be 2? Yeah, so for 1 over K to be 2, what does K have to equal? K has to equal 1 over 2. Okay. Reflection in the y-axis. Well, that means we're going to have a negative K value and a translation left. Translation left means D is going to be minus 5 and then up 4. So C is going to be positive 4. All right, so let's fill it in. So let's start with the general form. Y equals A times F bracket K times bracket X minus D bracket plus C. Okay, so Y equals A is 3. So start with that. Function, we don't know what the function is. Leave it as F. K is going to be negative and it's 1 over 2. Then we have X minus negative 5, which becomes X plus 5. And close our brackets. Afterwards, you have a plus 4 on the outside. And there is your equation. Okay, so that's a quick look at combining all the transformations together, creating your graphs, and also creating equations. So that ends this video.